Okay, so we completed constant velocity. We did some work with v bar equals d over t. We solved those equations. We learned about scientific notation a little bit, or reviewed it, I guess you could say. Well, let's move now to section number 2, average velocity. Average velocity. Now, oddly enough, even though students have a considerable amount of experience with average, they still get average velocity kind of confused. Okay, so I will do my absolute best to get it clarified for you, if you do your absolute best to clarify it yourself, kind of thing. So, okay, so average velocity, or v bar, average velocity can be determined 2 different ways, and one would be by formula, which is of course what we're going to look at right now. Now really, average velocity, constant velocity, by formula, really the same thing. Okay, because in all of these questions here, okay, like a motorbike traveling at 85 kilometers an hour is shown, okay, that might be a constant velocity, right? But for the most part, the process is pretty much exactly the same. Okay, so let's do a couple examples here. So a bike travels 3.2 kilometers in 45 minutes. What is its average velocity? Pretty easy to do. Pretty easy to do. All right, so v bar equals d over t. So we're simply going to go 3.2. Now 45 minutes. I got kilometers and I got minutes. What should I probably do here? Probably convert to hours. Now, can you just convert 45 minutes to hours in your head?
Yes.
We all know it's
3/4.
3/4 of an hour, which is what is a decimal? 0.75. What if it wasn't 45 minutes? What if it was 47 minutes? Because it's not always going to be nice like 45. What would you do? Well, what we really did was we really took 45 divided by 60 to get my 0.75, right? So if it's 47, you're just going to take 47 divided by 60, right? It's 47/60ths of an hour. Okay, so what's 3.2 divided by 0.75? It's going to be more than, right? 3.2 divided by 0.75. 4.27 kilometers per hour. What about number 2? A vehicle travels 30 kilometers east in 15 minutes, 45 kilometers west in 20 minutes, and then 10 kilometers east in 7.5 minutes. What is its average velocity? Now, do you get the sense that this one's a whole lot harder? How come, Connor?
Because it has like east and stuff.
East and stuff.
Direction.
Direction, thank you, yeah. Now, we're lucky in that we're going east and then west and then east, right? So we can sort of set it up ahead of time that to the right is positive and to the left is negative, right? Okay, so let's just figure out what's my, now average velocity is, now can I just, there's 2 ways to look at this, right? Could I just go 30 kilometers divided by 15, and then 45 divided by 20, and then 10 divided by 7.5, figure out the 3 velocities, and then add them up and divide by 3. Could I do that?
I guess so.
I could, but then I would be doing it wrong.
Oh.
Awesome.
Why is that wrong?
Not all in the same direction.
No, I don't think that would cause that to be wrong. Let me put it this way. If you took all of your assignments, right, and some were out of 10 and some were out of 100, and you just took your average on each one, would that be an indication of your overall average?
Because they all have the same.
They got to have the same denominator, right? They got to be out of the same thing. They got to count the same amount, right? If I give you a 2-mark true and false quiz and then an exam, you're not just going to average those 2 together, right? Doesn't make sense. The weighting's not the same. Same thing here. This is 15 minutes. This is 20 minutes. This is 7.5 minutes. What if this wasn't 15 minutes? What if this was 17 hours? Well, clearly the 30 kilometers east in 17 hours would count more, right? So you can't just add up the 3 and divide by 3. Okay? What you have to do is you have to find the total displacement. And the total displacement is 30 kilometers east, so that's 30. and then 45 kilometers west, so that's going to be minus 45, and then plus 20 kilometers, or sorry, plus 10, right? So my overall displacement is 30, minus 45 is minus 15, plus 10. My actual displacement is minus 5. I have to figure out my overall displacement, which means I also have to figure out my overall time. I have to figure out my overall time. So I've got 15 minutes, 20 minutes, 7.5 minutes. And I apologize for the poor writing here, but I have to get this file remade. 42.5. Right? I have to take the total displacement, I have to get the total time. And now hold on here. That's 42.5 minutes, isn't it? So what do I have to do? I got to convert that. I got to go 42.5 divided by 60. Is, no, it's not. Calculator issues. I don't know what's going on with the calculator here. Alright, sorry about that. So that's going to be 0.71 hours. Is that what you got? Let's put that down here. Okay, so now we go V bar equals D over T. So now I take my minus 5 divided by 0.71. So 1. So it's minus 5 divided by 0.71, giving me an average velocity of minus 7. That's going to be kilometers an hour. Minus 7 kilometers an hour. Okay? So that actually was considerably harder than sort of first look, right? We had to find the total displacement, then we had to divide it by the total time, which we had to convert to hours, and then we used V bar equals D over T.
You get a minus kilometers an hour.
Just means that your average speed is to the west, that's all, right? The average velocity.
Oh.
Okay, so if I move now down to number 3, say if I move down now to number 3, that didn't work out so good, did it? No. Yeah, I'm really not liking this today. What am I going to do with number 3? An orienteering athlete walks 1.2 kilometers east in 25 minutes and then 0.5 kilometers north. So what's different about this one? It's not positive negative anymore, it's east and then north. Here we go again. Alright, now I know I can draw. Okay, so I've got east and then I've got north. So what is my overall displacement? I'm going to have to solve this by what? Vector addition. I'm going to have to go 1.2 east, then I'm going to have to go 0.8 north, and then I'm going to have to find D. And then I'm going to have to find my total time, and then I'm going to have to determine my average velocity. I'm going to give you a minute or so to try that while I go mark attendance. You do actually have the skills to do this. You should. Okay, let's see here. So, just going to remind you again, the athlete walks 1.2 kilometers east, that's this vector here, and then 0.8 kilometers north in 15 minutes, right? Determine the average velocity. So the first step is to find the overall displacement, which I've marked here in red. And I'm going to do that by Pythagoras. I can do it by Pythagoras because it's what kind of triangle? A right triangle, because it's east and then it's north. There's no angles involved, other than 90 degrees, right? So D is 1.2 squared plus 0.8 squared. 1.2 squared plus 0.8 squared. And then don't forget to take the square root. And I get 1.44. Okay, 1.44 kilometers is my displacement. Next step, find the total time. 25 minutes, 15 minutes. 40 minutes, right? 25 plus 15 is 40 minutes. Convert that to an hour by dividing by 60. 0.67 hours. Right? Now, V bar equals D over T. Total displacement, 1.44. Total time, 0.67 hours. So 1.44 divided by 0.67 gives me an average velocity of 2.15. 2.15 kilometers per hour. And does anyone get the nagging feeling that we're not done?
No.
Why, Mackenzie?
Do you have to find the angle? I do that.
Why do we have to find the angle?
It's a vector.
Because it's a vector and it has magnitude and direction. And the general rule is if you've got east or north or west or south in the question, you're probably going to need it in your answer. So it's going to be inverse tan opposite over adjacent, get your angle. And I get 34 degrees, and that's going to be east, and then 34 degrees to the north. Lots going on here. Hello. Yeah. Technically, yeah, you should. Okay, flip the page over. Now, the other way to calculate average velocity is by determining the slope of the line joining 2 points. So, the other way to find average velocity is to determine the slope of the line joining 2 points. So, in this example here, the slope of the line in time interval A would yield the average velocity for that time interval. And we've seen this already, right? If I want to find the average velocity for interval A, I find the slope of that line, and that would be a rise of 6 over a run of 2, 3 meters per second. Right? Okay, you don't have a lot of room there, but at the bottom it says determine the average velocity for the remaining intervals as well as the entire trip. So I want you to tell me what's the slope of the line for intervals B and C and D and E, and what are we going to do in F? It's not a... We're going to do what, Nick? Tangent is for instantaneous velocities. We're dealing average, so we're going to join the two endpoints. Okay? We're doing the average, so we're going to join the two endpoints. So go ahead and tell me what's the slopes of B, C, D, E, and F. Well, I hope you didn't do too much calculations for B, because B is clearly 0. It's flat. Well, it does. It's 0. Let's see. It's going to be, it starts here at 6. It goes way down to minus 10. So C is going to be, it goes down minus 16 and over 1, 2, 3, 4. So you should have got minus 4. Did you get minus 4? D again is 0. E, the slope of E is, now this is up from minus 10 to 4, so that's up 6 and over 1, right? So just 6. And remember with F, you want to go from endpoint to endpoint, so we're up 4 and over 1, 2, 3, 4, 5, so I think that's 0.8, right?
Yep.
Good?
Yeah.
Give me the nod, yeah, I'm good. Okay, because when I see nods, then I go, okay, they're good, I can move on. Nods are good. Okay. Okay, so remember here, I'll just flip back to this one here, just to read through this here.
What about the average velocity?
Oh, for the whole thing, we were supposed to do that, weren't we? Right, we were supposed to do that.
0.
We were supposed to do the average velocity for the whole thing. Who was that said it was 0? Alex? How come the whole overall average velocity is 0? I started at a displacement of 0. I started at my start point. I end at my start point. I didn't end up going nowhere, right? I ended up at the same spot. I didn't end up going nowhere. Oh, the English teachers are not happy with me. Okay, so quickly here, on the next page, when determining the average velocity, the following points should be kept in mind. Positive slope rises to the right, yields positive velocity, and negative slope drops to the right, yields negative velocity. Positive velocity results in moving in a positive direction, negative velocity results in moving in the negative direction. Straight line portion on a graph indicates constant velocity. This means that the average and constant velocities are the same. If the average velocity over more than one straight line portion of the graph is desired, then you must construct a straight line from a point on the graph at the beginning of the time interval to a point on the graph at the end of the time interval. Okay? In other words, if I wanted to figure out what it was for instead of the overall, what if I wanted to say figure out the average velocity for intervals A, B, and C? Casey, how would I do that? Yeah, from A to the end of C, exactly. I'll do it in blue. It would just be the slope of that line, right? Okay, that would be the average velocity for A, B, and C. That's good. Okay, and last one, obviously there, D, a horizontal line indicates 0 slope and therefore 0 velocity. That is the object is stationary. Okay, moving on now to the third one, instantaneous velocity. Instantaneous velocity is when we have to concern ourselves with what kind of line? Tangent lines. Is that what the sound effect was for? Okay. I wasn't familiar with that one. I didn't realize tangent lines had a sound.
Oh yeah.
Apparently they do. Yeah, it's good. Good. I'll have to use that in the afternoon class. There are two possible conditions where V inst is to be calculated. Now, if I'm asking you for the instantaneous velocity of a straight line, well, in this case, V inst is equal to V bar because the velocity is constant, right? So whatever the slope is for the whole thing is the slope of the line at that point and 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 that point, right? The slope of interval A is the slope of interval B is the slope of interval C, and it's the same as the slope at individual points. It's easy. Instantaneous velocity on a straight line graph, you just find the slope of the line. Does it matter which 2 points you pick? No. How come? Because it's straight, it doesn't matter. Flip the page. Okay, now if it's curved, this is where we got to talk about tangent lines. Now, calculus professors can make this far more confusing than it needs to be. I'll attempt to not do that. It says on a curved line graph, in this case, the portion of the graph over which the V inst is to be calculated is reduced as shown in the diagram below. In other words, if I want to find the slope of the line at that point right there, well, I could sort of approximate it by taking the average from endpoint to endpoint. But if I get a smaller interval, if I go from that point to that point, well, that's a better approximation. And if I take an even smaller interval from there to there, well, that's an even better approximation. And if I could zoom in and get closer and closer and closer and closer, well, the curved line eventually becomes straight. Okay, that's sort of the calculus explanation. Okay, and that's sort of what we're talking about here. And what you do is you zoom in closer and closer and closer and closer, and then you draw a line on top of that little almost straight line, and then you just extend it, zoom out, and then you've got yourself what we call a tangent line. Okay? That's sort of the theoretical. In the real world where we all live, what you really do is you take a ruler, right? You take a ruler and you just put your ruler up against the curve and you draw the best tangent line you can. And as I pointed out earlier, okay, Ian's going to get a different one than Mitchell. Okay? They're going to be slightly different, but that's okay. Okay? Not really sure that has anything to do with it. Okay? And then you pick 2 points on the line and do what? Just find the slope. Pick 2 points on the line and find the slope. Okay. So I want you to try. You're going to need a straight edge. You don't necessarily need a ruler. The edge of a calculator will work. The edge of a textbook will work. Anything straight will work. Okay? I want you to tell me what's the slope of the line at A, at B, and at C. All right. Now, normally I would do this in Smart Notebook and get the ruler up, and it's really, really hard for me to do. It's almost going to be impossible having to do it in words. So what kind of answers did you get? Obviously, A is going to be, like I can't even draw on there, right? It's going to be positive. What'd you get for an answer, Beth?
I'd rather not say.
You'd rather not say. Tristan, what did Ben get for an answer?
Right.
What did you get for an answer, Lloyd? 0.5?
See, my answer is the same. I got 1.3.
You got 1.3. All right, well, let me find mine, I guess. Let me see if I can. For A, I got 1.2. Now, that's not to say that mine is the correct answer at all, by any stretch. Is it? Oh, well, then it's got to be right.
So when you're marking this like a test, how do you know?
Really what I do is I look to see, have they drawn a tangent line? Is it at all remotely close to a tangent line? Like if you've got a line that goes like, like that, then no, right? It's got to be a straight line. And if you pick 2 points and if you show me the work, I mean, it's not about the answer, it's about do they know the process, right? I mean, if you made a mathematical error, then I would probably deduct for that, right? But for the most part, if you've shown the work, I'll give it to you. So, I mean, in this case here, and it also depends on the scale, right, too. I mean, if these are up by thousands, then there's going to be a huge difference. So, anywhere between about maybe 0.7 and about 2, I would just automatically give it. And anything outside that range, I'd have a closer look. Okay? What'd you get for B? Now, B is kind of tricky because it's almost a straight line there, isn't it, right? So it's really not so much a tangent line because it's going to touch it more than once. So you have to draw a line that estimates or approximates the slope of the curve, and I got about 2. What you got? Roughly 2? 2-ish? Okay. And then C is going to be negative. I got minus 1.5. So somewhere between minus 1 and minus 2 would be automatic. Alrighty? Okay. You got a little bit of time left in class here. You should have 1, 2, 3. You have 4 graphs here. Okay, so what I would like you to do is I would like you to take the remainder of this period. Let's say for tomorrow, I would like the first 2 done. How does that sound? Okay? For tomorrow, let's get the first 2 done. There are answers on the back. You can check. I know there's a little problem with one of the answers, but I think I fixed it. Okay, so get 1 and 2 done for tomorrow. We'll check them, and then I'll give you a little bit more time to finish up tomorrow.